All right, let's get started with this. All right, looking at the first part here, the difference of squares. All right, I'm looking right here. All right, a squared minus b squared. If we have two perfect squares that are being subtracted, all right, we can have a difference of squares, all right, and we can factor that by finding a. And remember that in order to find a, and I'll just write this down here for now and then erase it, all right, if we have a squared, which is our first term, right, in order to get a, what we need to do is square root the first term, and then that's how we find what a is, okay, so that's where we get this letter right here, a, all right. So we'll go over this again in detail in a second with some examples, but that's how we figure out what a is. And then, of course, the second term is b squared, right? So when we square root the second term, which is b squared, that's how we end up getting b, and we plug that right back in where we see b, all right? As far as difference of cubes, all right? Or excuse me, sum of cubes is next. All right, same thing. We have a plus b, a squared times a squared minus ab plus b squared. All right, same thing here, all right, except we're using cube roots instead of square roots. Okay, so if you have a cubed, how do we find a? All right, being the first term. This is what I'm talking about. When we see the first term, we take the cube root of it. What number multiplies together 3 times to get a cubed? Well, a times a gives us a cubed. So if we take the cube root of the first term, that's how we get a, which we can plug into the multiple spots that we see a, right? Right here as well. And then for b, the second term is b cubed, right? And again, in order to figure out what b is, we take the cube root of b cubed. What number or variable multiplies together 3 times to get b cubed? B, right? So there we go, right? That's what we get. We get b, and then we're just going to go ahead and once we find that, plug that back into this. We'll call it a formula, all right? All right, let me erase that. Oops. Let's do that instead. All right. Same thing for difference of cubes, except this time, right, you just have to recognize that we have subtraction of two cubes, difference of cubes, okay, difference of cubes, okay. Let's go, I'm going to go through the odds, as I said, all right, and you guys can do the evens on your own. The answer key is posted, so if you're having any issues with a specific problem, just reach out to me and I can help you guys out with that, okay, I can send individual videos, whatever it might be. All right, so for number 17, all right, first thing we got to look at is, do we have a GCF? And we do. All right, that GCF is 3x squared. All right, so there's our GCF, 3x squared. All right, so we're going to put that on the outside. We have to divide each term by the GCF. All right, and we end up with 3x plus 7 inside of the parentheses once we have done the division. Our quotient rules, our exponent rules as well. All right, so there we go. We have our two terms, or our two factors. Is there anything else that we can do? No, there's not. All right, so this was simply just a finding the GCF problem. Okay, so once you get down, you cannot factor anymore. You know that you are done. All right, on to number 19. All right, do we have a GCF? Well, no, we don't. All right, not at the time, not at this time. But what I do notice is we have perfect cube and a perfect cube. 343 is also a perfect cube. What number multiplies together 3 times to get 343? If you have your cube root chart, you'll see that that is 7. 7 times 7 is 49. 49 times 7 ends up giving us 343. Okay, so let's go ahead and do this problem. All right, in order to find a, we got to take the cube root of a squared, which is this value right, or a cubed, excuse me, that value right there. So what is the cube root? What number multiplies together 3 times to get 64? That would be 4. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. And what number multiplies together 3 times to get a cubed? That would be a. So this is our a right here, right? And then as far as b, the cube root of 343 b cubed equals what number multiplies together 3 times to get 343? It's 7. And b multiplies together 3 times to get b cubed. All right. So this is our a term, and this is our b term. All right. So we just need to go ahead and plug them back into our difference of cubes formula. All right. So a minus b, so that would be 4a minus 7b, close parentheses, times, this is a squared, 4a squared, so 4 times 4 is 16a squared, plus a times b, so 4a times 7b. 4 times 7 is 28. Oh, I put 20a, 28 ab. And then finally plus b squared. 7 times 7 is 49b squared, and close parentheses. And that is our answer. We can't simplify this any further. We can't simplify this any further. We are all done, so that would be our final answer right there. Okay. Looking down at number 21, 2CD is going to be our GCF. All right, so if we're looking at this, they're both even numbers. We don't have any perfect cubes at this point. All right, no perfect squares at this point, right? Neither of those terms are perfect squares or perfect cubes, so we have to take the GCF out first. All right, the GCF, again, is 2CD. All right, let's put that on the outside of the parentheses, 2CD. All right, and then close parentheses. What we're left with when we divide out 32 divided by 2 is 16. All right, we take one c away. All right, c to the fifth divided by c to the first is c to the fourth, and d to the first divided by d to the first is 1, so that would disappear at this point. All right, and then the next one, minus 162 divided by 2 would give us 81. All right, c divided by c is 1, so we don't have anything there, and d to the third divided by d to the first would give us d to the second. All right, so that is what we're left with. And if you notice, inside of the parentheses, we have a difference of squares. All right, so again, to find a, we need to find out what number multiplies together 3 times here. Right, so I'll figure out a right here. What number multiplies together twice to get 16 is 4, so we get 4. And what multiplies together twice to get c to the fourth? That would be c squared. And then for 81d to the second, what number multiplies together twice to get 81? We get 9. D multiplies together twice to get d squared. All right, so this is our A and this is our B. So let's go ahead and write those out. All right, we are left with 2CD on the outside and A plus B, A minus B. So 4C squared plus 9D times 4C squared minus 9D, and close parentheses. That is our final answer right there. Nothing else can be simplified at that point. All right? So we could box that answer. Very good. All right, working our way down to 23. All right. GCF is 2C. All right, so let's write that out. GCF is 2C. All right, so we're going to put that on the outside. And simplify this, divide them out. We get c to the fourth minus c squared minus 30. All right. So GCF has now been taken out. Now, if you notice this, we have potentially special trinomial factoring. Okay, so you can't just say we're done, right? Notice that right here we have, right here we have our c to the fourth, right? So c squared times c squared, right, would give us c to the fourth, right? And you notice that we have the c squared here, right? That really alerts us to what's happening here, right, in our special trinomial factoring. Again, if you want specifics on that, right, you can go to the special factoring video that was posted. All right, so here's what we're going to end up having. Let's try to find two factors of negative 30, right, that end up equaling negative 1 when we add them, right? And that would end up, I don't know why it's doing that. That would end up being negative 6 times 5, all right? Negative 6 times 5 gives us negative 30, and negative 6 plus 5 gives us negative 1, which is B right here, all right? So our answer for this, all right, is going to be 2C. Our first term, as we talked about, is c squared minus 6 times c squared plus 5. And there's nothing more that we can do. That is our final answer. We don't have a difference of squares. All right, right here it looks close to a difference of squares, but 6 is not a perfect square, so therefore it is not a difference of squares. Last one, we have our grouping. All right, so we have 4 terms. You know it's grouping when you have 4 terms. All right, 4 terms. 1, 2, 3, 4. All right, so we're using the grouping method. All right. What is our GCF of the first? N squared. Right, so we'll put the n squared on the outside. And we're left with n plus 2 when we divide it out. The next one, our first term is negative. And what I said, if the first term's negative, we're taking out a negative GCF. So our negative GCF will be negative 36. And when we divide that to each, we're left with, again, n plus 2, as we should be. All right, if we don't get the same thing, first of all, double check if you don't get the same binomial, right? Make sure that you didn't make any mistakes. But if you don't get the same binomial, it means it's prime and can't be factored any further. All right, so now we put these together. I'm going to cross this, keep this over here. So once we put them together, all right, we are left with n squared minus 36. It doesn't matter which order you put these in. And then combine the two binomials that are the same, n plus 2. And we would be done if we were done. But we're not, because we have what? We have a difference of squares. Hopefully you were able to recognize that, okay? So a, what is n squared? N squared is n. That will give us our a term. 36 squared is 6, so there's our b term. So we are left with n plus 6, n minus 6, and then this is going to come down. We have to keep that. N plus 2, and do not forget, I should have honestly had this right in front of that as well, but we need to have our GCF that is out in front. Oh, no, we do not. I apologize. That was because we were doing the grouping method. We're done. That is it. I did it all right. I questioned myself, and I was wrong. That's part of math. All right. So we do not need to put this GCF on the outside because it's part of our grouping method. All right. That's why we didn't put that. In fact, we have that GCF is right there, n squared. All right. So again, part of the grouping method. My apologies there. All right. Let's go to the next page and get this finished up. We have 3 more problems to go, and we're going to keep this way under 30 minutes today. So for number 27, all right, we have a GCF of 2x squared. All right, so we're going to take the GCF out here. All right, so 2x squared. Sounds like we got a fire by our house. It's great. All right, not really, of course, pray for those people. All right, x squared minus 24 equals 0. All right, now, do we have a difference of squares? No. No, we do not. 24 is not a perfect square, so it kind of looks like it, but we're done here as far as factoring goes. We can't factor this any further, so this is where we make our little chart-looking thingy, all right? And we set each of the factors equal to 0, right? So we have 2 factors, all right? So 2x squared equals 0. Divide by 2 to both sides. We're going to get x squared equals 0. Right, take the square root of both sides to get x by itself, and x equals 0 here. So that's our first solution. The next one is x squared minus 24 equals 0. All right. X squared, we add 24 to both sides and get x squared equals 24. All right, and again, taking the square root of both sides here to get x by itself, and we get x equals plus or minus the square root of 24. But is 24 simplified? Can there be a better way to do this? All right, well, the 2 factors of 24 would be the square root of 4 times the square root of 6. Do we have a perfect square in there? We do. 4 is a perfect square. So we can simplify this, right? This would end up being x equals plus or minus, what is square root of 4? 2 times the square root of 6. Bada bing, bada boom. There's our 2 solutions. So we can write that out as x equals 0, comma, plus or minus 2 square root of 6. All right, 29. Everybody see that, hopefully. All right, 29. First issue here, we need to get the right side equal to 0. All right, that's very important. You need to make sure you get the right side equal to 0. So we need to subtract 5 from both sides. All right, subtract 5 minus 5. There's a like term right here, so we can combine those like terms. All right, so we're left with, and we'll write it right here, 108x cubed plus 32 equals 0. All right, so we're left with that. Do we have a GCF? We do. All right, our GCF is 4. Right, so again, have a calculator out. That's totally fine. Our GCF is 4. So put the 4 on the outside. Do not forget that through the rest of the problem. Right, and we're left with 27x cubed when we divide that out plus 8 equals 0. And are we done? Hopefully you notice that we have a sum of cubes. All right, we have a sum of cubes here. This is a perfect cube, and this is a perfect cube. All right, so we have a sum of cubes. So that means we need to do the sum of cubes formula. All right, what number multiplies together 3 times to get 27? That'd be 3, and x multiplies together 3 times to get x cubed, and then 2 multiplies together 3 times to get 8. All right, so this is our A, this is our B here. So we're going to go ahead and plug that in, and when we do, we end up getting 4 times A plus B, 3x plus 2, close parentheses, and then 9x squared minus 6x plus 4. And that's all equal to 0. All right. So now we are all set. We can't factor that any further. All right, we could try to do that method, A times C method, right, where we do this. You would do that, and you would end up not getting, it's prime. There's nothing that you can do. Once you do the A times C, you'll realize that you cannot get that answer. So we can't factor it any further, but there is something that we need to do. It's a trinomial, so we're going to end up having to do quadratic formula for this. Right? How do you know when you need to do quadratic formula? If you're left over with a trinomial that cannot be factored out any further, yes, you need to do quadratic formula. All right, so we're going to get into that. So let's do this one first. 4 equals 0. That's ridiculous. 4 doesn't equal 0. No, it doesn't. So that is not a solution. All right, so if it's not equal to it, right, we just have a number, 4 equals 0. That's not a solution, so we're done with that. Okay. Next one is 3x plus 2 equals 0. Subtract 2 from both sides. I'm going to save space. It'll end up being 3x equals negative 2. You guys got that algebra down at this point, right? Divide 3 to both sides, and we get x equals negative 2 over 3. That's a negative sign right there. All right, negative 2/3. And then finally we have to do the quadratic formula, right? So the opposite of b, plus or minus b squared minus 4ac all over 2a. All right, have that out in front of you as you do the quadratic formula. All right, so when we plug it in, right, remember that this right here, this is our a, this is b, and this is c for when we're plugging in. All right, it's in standard form. All right, so let's go ahead and do that. Quadratic formula, here we go. X equals 6, the opposite of b, so 6, the opposite of b. B is negative 6, so the opposite of that will be a positive 6. Plus or minus the square root. It's going to be make that a long square root there. B, negative 6 squared, minus 4 times AC, 9 and times 4. All right. Once we combine this, remember I always do, and then we have to do over 2a, excuse me, on that. Everything over 2 times 9. All right, now remember, I do this, then I multiply these, and then I just go ahead and add or subtract them together. In this case, would be subtract. Once you do that, you end up getting x equals 6 plus or minus negative square root of negative 108. Oh no. Oh yeah. We're back. All over 2 times, this is a 9 right here, right? Which would give us 18. All right. So now we need to simplify negative the square root, okay? And it's negative, so that means we're going to have to deal with imaginary numbers here. All right, so once we do that, we need to find the 2 factors of 108, all right? That will end up equaling 2 factors that end up equaling 108, 1 being a perfect square. All right, so 36 and 3, right? 36 times 3. So those are our 2, right? Those are the 2 that will give us the 36 being a perfect square, right? So we'll be able to simplify it using that, right? So once we do that, remember we have to take out the I for the negative, so it's 6 plus or minus the square root of 36 is 6. I, right? So that's for the negative, and the square root of 36 is 6. That's what that's coming from. Left with the square root of 3 on the inside. All right. Let's see here. And that's all over 18. And then last thing we need to do is figure out whether or not there is a GCF between the coefficients and constants. All right, 6, 6, and 18. There sure is. 6 would be the greatest common factor, so we need to divide each of those. 6 divided by 6 is 1. 6 divided by 6 is 1. And 18 divided by 6 is 3. So our final answer for this problem right here is x equals 1 plus or minus 1i, or just I, square root of 3 all over 3. And that is the answer, including, don't forget, over here we have x equals negative 2/3. Okay, and the last problem here, and we'll call it a day. We have special trinomial factoring. All right, two factors that multiply to get negative 20, but add up to get positive 19 would be 20 and negative 1. So we end up getting x squared minus 1 times x squared plus 20. Okay. Now, you could factor this further, all right, but I do want to show you something here. It's interesting. I'm looking at the answer key right now, and I'll do it the way that the answer key has it. But you can still get the right answer here, even if you don't factor it all the way. I would suggest factoring it all the way. In fact, you can look at the answer key and see what they did. I'm going to factor it all the way because that's the way I would do it, all right? So x and 1 for the difference of squares. So it's x plus 1, a plus b, x minus 1 times a minus b, right? And then we're left with x squared plus 20. Nothing we can do with that. All right, and this is all equal to 0. We should make sure we have that there. Okay, let's make our little chart. Give myself some space there. All right, x plus 1 equals 0. Subtract 1 from both sides. We get x equals negative 1. For the next one, x minus 1 equals 0, right? Add 1 to both sides. We get x equals 1. And then x squared plus 20. We get x squared plus 20 equals 0. Subtract 20 from both sides. We get x squared equals negative 20. And then we have to take the square root of both sides. And we get x equals plus or minus the square root of negative 20. Yikes, we got negative 20. It's not good. We can't have that, right? Well, we can now. We have imaginary numbers. So hopefully you're following along with that. All right. 4 times 5 gives us that. So what we end up doing, square root of 4 times square root of 5. All right. We have a perfect square in 4. So this ends up becoming x equals, what's the square root of 4? 2i for that negative sign. All right. That's now going to be taken out, and we're left with square root of 5 as our answer. So our final answer for this, that's going to be plus or minus. Make sure you have that. My mistake there, right? Plus or minus 2i square root of 5. So we are left with x equals plus or minus 2i square root of 5, comma. If you notice, look over here, we have negative 1 and 1, right? Well, we can just make it like this. That's kind of a shortcut, right? Plus or minus. Can be a positive 1 or a negative 1, and that is our final answer. That is our quiz review. All right, I am going to open up a Zoom meeting on Monday morning. All right, if you want to wake up and join me in a little meeting to go over anything that you're having trouble with, I will send you guys a link via email. It's pretty simple. If you have a laptop, I think it works best. I think there's an app as well, a Zoom meeting app. All right, so if you want to look that up. If there's any issues with it, don't worry about it. Go with the flow. All right. I am going to be flexible. If you're having issues, just make sure you're communicating with me. And remember what I said. All our videos are going to be 30 minutes or less per day. All right, I'm trying to reduce the workload. But again, I want you guys to learn. Right? All the teachers do. We want you guys to get better and continue to learn, even though we're in these weird circumstances. And I want to say that this has been kind of a blessing to have teaching still available. It's something that the teachers at Curly are very passionate about. It's our job, and want to thank you guys for your efforts and your hard work in this time. And just I ask you to keep it up, keep up the hard work. Proud of you guys, and hopefully we get back to it soon at school. Miss you all, and I will talk to you soon. All right.